look at another application of integration. This is what we call kinematics, and you will probably remember kinematics from when we did differentiation. So you remember when we did differentiation, we talked about distance and changing it into velocity and changing it into acceleration. And we said that if you were doing that, if you're going along that process, was differentiation. So if you started with a distance function and you differentiated it, you got velocity, and if you took velocity and differentiated it again, you got acceleration. Now, I've been telling you that integration is just undoing differentiation. So if going that way is differentiation, then it makes sense that coming back this way is integration. So this makes sense that this is integration. Okay, so if we've got something that we know something about acceleration, we can work out the velocity, and if we know something about the velocity, we can work out the distance simply by integrating. Okay, let's do an example. That was a good example. The thing that I know when I drop something is that acceleration is constant. So when I drop something, so under gravity, acceleration is 9.81. Except we're doing a maths class, not a physics class, and I haven't brought a calculator with me, so I'm going to call it 10. Okay, so we're going to say the acceleration is 10 meters per second squared. And that's just a constant. So we know that that's a constant. So it doesn't matter what the time is. So acceleration at any time is 10 meters per second squared. Okay, so let's have a go at figuring out what the velocity is going to be and what the distance is going to be. So what we're saying is that the velocity at a particular time should be the integral of the acceleration, which is just the integral of 10. And if we integrate 10, we get 10t plus a constant. This is an integration, so you have to have a plus constant on the end. So yeah, so when we integrate the 10, integral of 10 is 10t plus a constant. So this constant is a velocity thing because it's part of the velocity function, and we've got to decide what that is. So if I'm just dropping my thing, then at the start time, when t equals 0, the velocity will also equal 0. So for a drop, the velocity at 0 equals 0. So 10 lots of 0 plus c has to equal 0, which means that c equals 0. So c is effectively the initial velocity. So if I just drop it, it started with 0 velocity. If I threw it down, then the speed I let it go with would be the value for c. Okay, so c just gives you a handle on what's happening at the start. So let's assume that we're just dropping it. So my velocity is just 10 times t. And that lets me work out the velocity at any time. So after 5 seconds, if something's been falling for 5 seconds, it should be going 50 meters per second. And now I can work out the distance as well. So if I come back to finding the distance is just the integral of the velocity, which is the integral of 10t dt. If I integrate 10t, I get 5t squared. Again, plus a constant, but that constant's just measuring how far away it is from the start. So if I'm going to take my 0 start, as where I drop it from, then that'll be 0. But if I was measuring from here and dropped it from here, then that distance would be the constant. So let's assume we've just dropped it from the start, and we can obliterate that, and we now know the distance is 5t squared. Okay? So if something falls for 4 seconds, how far is it going to fall? Well, 4 squared is 16, times 5 is 80. So it'll fall 80 meters in 5 seconds. Okay? So we have a handle on, just because we know the acceleration, we can get a handle on the velocity and on the distance. And for those of you that are doing any physics or engineering fundamentals, you may remember the formula that says S equals ut plus a half at squared. If u is equal to 0, so I'm just dropping that bit 0. And if I've made a equal to 10, half of 10 is 5. Right. That's where that formula comes from, this sort of idea of being able to work back from acceleration, fixed accelerations. Okay, so in terms of kinematics, distance to velocity to acceleration is differentiation. Going the other way is integration. It's just a matter of doing the integrations, and you do need to be a little bit wary about these plus c's that pop up, which are basically dealing with the initial conditions. So what was it doing at the start? If your starts are all zeros, those can be ignored, but if it starts with a particular speed, then you have to put that into account in that point. But that's really all there is to it, and this lets you go both ways. If you've got a function, you start with a velocity function, you can work out acceleration by differentiation or distance by integration. Okay, so that's really the guts of what there is in the kinematics.